All right, so I'm gonna start you from the beginning. It's okay. So you should have talked about exponential functions in Algebra 2. I hope you remember them. They look...
Well, first of all, it is frozen on whatever that is.
Still.
What?
Yeah.
Oh, sorry. Yep.
It is. It is 12.
So it got where I said
Yes. All right, so here's what an exponential function is. We have these two things that multiply together, but then the second number, the variable has to be in the exponent. Okay? That's what makes it an exponential function. So the variable is the exponent. So let's see. The b is what we call, now my thing's not going to work with me. It's what we call the base, because when we have an exponential piece that we've talked about before, you know, we have the base and then we have the exponent, and together they make up the exponential function. The number in front is our a. If that happens to be missing or you don't see it, what value do you think it has? 1. 1 because it's being multiplied is y. Okay. Another thing to note is that b is never negative. Okay. It's never negative. If there's a negative in front, the negative goes with a and not with b. Okay. I'm going to give you a second to catch up. Then I'm going to show you a couple examples, and you're going to tell me if they're exponential or not.
So we're saying yes or no?
Mm-hmm. And we're going to do a little bit. Let me give you a couple. You tell me yes or no exponential functions. Okay. Here we go. Yes or no exponential function?
No.
Yes.
What? You just said it can't be a negative.
Yeah, the b.
The b. So in this case, what is a?
-1.
What's b?
Oh, shoot.
So yes, it is an exponential function.
Okay. Let me write that down right quick.
B is the number that's hooked with the exponent.
Yeah. But I mean,
And if a is not there, it's 1. But because it's negative, okay.
Wait, so therefore, if there is an A and then the base is negative, it's not.
You won't have that.
What? Then how-
You're confusing yourself, I think. You're confusing me a little bit.
I understood.
Yeah. What? Some of them. No.
how many?
Exponential function, yes or no? Why? The x is not in the exponent. Okay? Do you see what we're doing? Should be pretty easy, I hope, at least. Yes? Yes. This one, no, because the base is the variable. Okay? Your variable has to be the exponent to be an exponential function. What type of function is this? Quadratic function. That's exactly right. All right. Let's go back to this parent graph. A times b to the x. Here's what I know. I have two types of exponential functions that I really talk about a lot. They're growth and decay. Do y'all remember doing growth and decay? Okay. Growth on a graph looks something like this. Dashed line is an asymptote. And decay looks like this. Y'all remember it? Yes, thank you. Yes, some of us do. All right, so looking at the equation that we're given, There's a way that we can tell if it's growth or decay. You remember what that is?
The leading coefficient.
The base. Okay? If the base, now remember B can't be negative, right? If it's negative, then the A is what's negative. If the base is bigger than 1, then we're talking about growth. But if the base is less than 1, we're talking about decay. And then we're gonna delve a little bit deeper. I want you to tell me if it's growth or decay. Whoa, I just threw some transformations in there is all I did.
Decay. I mean, growth.
Growth, why?
Okay, because it's bigger than 1.
Only thing you're looking for here is the B.
Yeah.
B is 2. 2 is greater than 1, which means it's growth. The negative in front does not
So
matter.
then what is the
What's that
negative 5?
Wait, what's the A?
Okay, so that negative 5, and we're going to do those in just a minute, that's a shift down. That's exactly. Remember, whenever you throw a plus or a minus something on the end of the equation, that's just an up-down shift.
That's just the C.
So it takes the graph and it goes down 5. Go ahead. The negative in front means that the A
It's 1, negative 1.
is negative
It
1.
was positive.
Well, I want you to be able to recognize it because in your homework it won't be like that. It'll just say negative whatever. All right? How about this one?
Okay.
Why?
Because it's a fraction.
The fraction itself is greater than 1. It's 1.5.
Well, I didn't do that because I don't know. Yeah.
Talk to it in one.
Growth or decay? Decay. What is B? B?
Oh,
1/4. What is A? Does that make sense to everybody?
1/4 is just 0.25.
Yeah. All right, so are we all okay on identifying if it's exponential and telling if it's growth or decay? Identifying A and B. Can we all do that? Yes, Miss Williams, we can do that. Good.
Yes.
Okay. Let's talk about graphing a little bit. So the way we're going to talk, or the way we're going to be graphing is we're going to talk about the parent function and then we're going to talk about some transformations on the parent function. So if I start with A times B to the X. Okay, some of these ones that I've been giving you before had a plus or a minus up top with the X or had a plus or a minus outside. Those are just transformations. Those are horizontal shifts and vertical shifts that we've done a lot of, right? Right.
Yeah.
Here's what you know. For every parent exponential function like this, we have an asymptote at y equals 0. That's on the axis. Okay, every single time. Every parent function like this, there is an asymptote at y equals 0. There's an asymptote at y equals 0.
For everything?
If it's ever in this form, yep. Here's the other thing. What happens if you plug in 0 for x in this? What do you get? You get 1 for this, but then you have to multiply by
0. So it'd be 0.
If x is 0, then y equals a times b to the 0. Anything to the 0 power is what? 1. So you just get... So what point is on every single one of these graphs? The point what? 0. Come on, y'all. 0a. Are y'all with me on that? Yes? That is the y-intercept of all these graphs. Y-intercept is where x equals 0, right? That is one point. The other point that is on every one of these graphs would be 1. What happens if you plug in 1? A times B. Right? Right. Now I'm showing you this because we're going to use the parent functions, then we're going to transform. So if we shift up, down, left, right, any of that, we're going to use these 2 points to shift. All right? Okay. Let me show you how we're going to use this. Let's say I had f of x equals 2 to the x. Yep. How is the second one different than the first one? Tell me what's happened to it. It's gone left 1. Do we all agree? Because when you add that 1 here to x, that's shifting it. So it's gone left 1 and it's gone down 2. Everybody agrees with that? Okay, so look back at the original. We know that the asymptote was at what? 0. So if I shift that down 2, where does the asymptote end up? At negative 2. So on this one, my asymptote will be does that make sense? Why? All right, when you add something to the x, that shifts it left. Right. And then whenever you put the number on the outside like this, that shifts it up or down. We're not worrying about shrinks or stretches with this right now. We're just worrying about shifts left and right, up and down. Okay? So look at anything added or subtracted to x or added or subtracted to the end of the function. All right, tell me what else you know about this parent one on the left side. Give me a point on that graph. 0, 1. Do we all agree? Because A is? So now if I shift this point, left 1 and down 2. So look at the left first. If I start at 0 and I go left 1, what is my new x? Negative 1. If I go down 2, what's my new y? This is saying subtract from x. This is saying subtract from y. I got 0, 1. Give me one more point on the parent graph here. 1 what? A times B, which would be 2. Once I transform it here, what does it become? Left 1, down 2. 0, 0. Left 1 means subtract 1 from the x. Down 2 means subtract 2 from y. You are. Don't think about it too. If you can come up with the transformations here in the middle, then you can just rewrite these points. Left is subtract from x, right is add to x.
Oh.
Up is add to y, down is subtract from y.
How can you find out some left, some down thing?
What do you mean, how can you find it? It's coming from this equation. When you add to x, that's left. When you subtract at the end, it's down. So now let's look at what it looks like when we graph it. That's all you need. All you need is the asymptote and 2 points, and you can do it. My asymptote is at -2, right? And then I have -1, -1, and 0, 0. Remember what growth and decay look like? It is growth. As it should be, right? Because b was 2. What's the domain on this? Always. What's the range here? Bottom up. -2 is the lowest it goes, up to infinity. That is. And that's the way I teach it in algebra too. When we get here, we focus more on transformations. But the number, did y'all hear the question? The number on the end is always your asymptote, because that's where it's shifted from 0. Let's look at another one. Una más. I got to show you the E on it, but it's the same concept. Let's say tell me what's happening. What's happening from F to G? Right 2. Which right 2 means take every x and add 2, right? So I'm going to put that in parentheses so you can really see. Add to x. And then what'd you say about y? Is anything being done to y? Up 1. So that's what we're going to add to y. If it was down, I would be subtracting, right? So let's look at what we got. Let's find what we know, and then we'll transform them. What's the asymptote on the first one? 0, right? So what is my new asymptote? 1. It's y equals, I add 1 to y. Okay. Give me a point. 0, 1. Right? If I transform it here, I add 2 to x, and I add 1 to y.
I hope you know that that's 0, 1 on there.
So it's always 0a, whatever your a is. And since there's not one there, it's 1.
Yeah, I got
All right, and then I can do 1, and I can multiply a times b. What's a times b? 1/2. All right. Add 2 to x, add 1 to y. What's your new point? 3. 1.5, or 1.5, or 3/2, or however it's easiest for you to do it. So you use 0a, and then you use 1a times b. If you plug in 1 for x, that's what you'll get every time. All right, let's graph. Should this be growth or decay?
Right.
What's b? B's a half. It's decay. Y equals 1.
But did you just say that 1/2 was growth?
No, bigger than 1.
No, she said 3 something, I think. 3 over 2. Yeah.
Yeah, 3 over 2 is the same thing as 1.5, so that's bigger than 1. Two, 2. 3, 1.5. There's only one way to connect these so that they hug the asymptote. Just like that. What's the domain? How about the range? I know that sounds crazy, but E is just a variable that stands for an irrational number. Just like pi stands for an irrational number, E represents an irrational number for us. And I'm going to give you the formal definition. You do not have to remember this, but since you do understand limits now, it's a little easier for you to understand the definition of E. So E is this number that if you could plug in infinity into this expression here, 1 plus 1 over x to the x, it would give you E, okay? But we can't plug in infinity. We can plug in numbers really, really big, but the bigger they get, the closer they get to this value of E, which is approximately 2.718. And it goes on forever because it's irrational. I gave it to you. I'm just telling you. It's not, you don't have to understand how you got it. I just wanted to show it to you since you understand limits and we've talked about limits. That if you plugged in as big a numbers as you could into this expression, you would be getting really close to this value. Now, understanding that E is just a variable that represents a number, then it is easy to graph with E. There's also a button on your calculator for E. So when we graph with growth and decay, sometimes there is an E. I am going to put, I don't want to use H or K. I'll use C. Or use A in front. All right, this is a value. Okay, that's exactly what it is. It's 2.7. But together with, sometimes there's a value written on the outside of the X there. Those together now make up your B. And I show it to you this way because if you just have Y equals E to the X, my first question is that an exponential function? Do you have a base with the variable as the exponent?
What is the B?
Yeah, so what would the B be here? What is A? 1. What is B? What's the base? Yeah, so it's just E, right? We know that E is like 2.718, da 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 da. So would that be growth or decay? Growth.
Is that CX over E?
Yes.
Or CX?
Because sometimes there can be a number in front. What if this was E to the 2x? What is A? What is B? e to the second. You got to take that. If there's a number in front of the x, you got to take it with it. Well, if you square 2.7, well, the x has got to be up there. You got to keep the x in there. If you have e squared, is that bigger than 1 or less than 1? Bigger. So it's... Can you think of something you could plug in for that number that would cause it to be less than 1 that would make it decay? Somebody said it. A negative exponent. What does a negative exponent do? Flips it into a fraction, right? So if I had e to the negative x, that would make my b e to the negative 1, right? Which would be 1 over e. Well, 1 over 2 is less than 1, so now it's decay. So the key here is, if this c is positive or not there, then it's growth. And if it's negative, we're talking about decay, and we're only talking about the C. We're not talking about the base, we're just talking about the C. This is when you see an E in there. C stands for a number, yeah. C will be a number. E will always, E stays, but it's an irrational number. You might be plugging some stuff in with E, but you've got an E button on your calculator.
What I'm saying is the only thing that we're worried about with this is that C number.
With that particular one. All right, everybody okay? That's, I know.